So lesson 4.3, we're going to look at simplifying expressions, and we actually already talked about this a little bit in the last lesson, so we've already got a little experience with this. And so we're going to talk about how properties of operations are used to simplify expressions. Just to mention here on the first page, 201, how can the tiles below be sorted? They could be sorted based off of being like terms, would be probably a way of doing that. So if you'll notice, we have 3 dominoes or tiles here that have X's on them. We've got a couple of them that have Y's on them. And then the rest of them are actually all constants. Even though some of them are fractions and some are decimals, they don't have variables. So that could be another set of tiles that we could sort out. So before we look at example 1, simplifying, like we already actually talked about this in the last lesson, we're going to look to distributive property and then combine like terms. Those are going to be the first 2 things that we're going to be trying to do. Okay, so when it says simplify the expression, those are the steps. Okay, first looking to distribute if we can, and then looking to combine like terms if we can. At that point, then it will be simplified. So if we look at example 1, teacher used algebra tiles to model negative 2c plus 3c minus 4c plus 7. And they want us to write the expression by grouping like terms together. So like terms together. Technically, what they're doing in the book, they are rearranging these. First of all, getting all their C terms together, getting all their constant terms together, and then they're adding them together. Again, technically, if you don't want to physically rearrange these, we can probably get by without that. One thing I would suggest when you do these, like we've talked about, is that if they are subtracting, you can add the opposite. So we've got negative 2c, 3c, and negative 4c. With having 3 like terms here, if you want to combine your positives together, combine your negatives together, and then combine them all together is not a bad way of doing this. So like negative 2c plus negative 4c would be negative 6c. And then we could say negative 6c plus 3c would be negative 3c. On the constants, we actually only have 2 constants, negative 5 and 7. So if you combine negative 5 plus 7, we have more positives by 2. And so negative 3c plus 2 would be our simplified answer. Again, the book rearranged them basically, but then you really have to be careful about your signs. Adding the opposite, highly recommend that you do that when you're going to simplify. The other thing is what they did here with these algebra tiles. Kind of visually you can see how negative C's and positive C's cancel out, and how positives and negatives cancel out. And then we're left with negative 3c plus 2. It's not a bad idea with these algebra tiles. It's just not always convenient to necessarily draw all these things out every time you do a problem. But again, if this visualization helps you kind of see what's happening, then that's good. So if we look at the try it, they're asking us to simplify this expression. Once again, anything where they are subtracting, I would recommend that we add the opposite. So 2 sign changes changes the subtraction to addition, and then we do the opposite. Always 2 sign changes when we do that. Okay, and then at that point we're going to be looking for like terms to combine. Again, the book is rearranging this. If you notice the blanks, they're basically rearranging these so they get the F's all together. So if you wanted to fill in the blanks, we could put negative 6F in the first blank, and then a 6 in the second blank, and a 9 in the third blank. But like I said, realistically, I would just do it this way, add the opposites, and then just try and look for like terms. Okay, there's not like a million different terms here, so we can probably, figure out where they're at and group them together kind of in our minds rather than rewriting the whole thing if you want. So if you want to, I usually like to start with the variable terms. So we've got a negative 6f plus a negative 3f. We've got a bunch of negatives working together here, so that's going to be a negative 9f. Okay, kind of like if you ignore the f's, negative 6 plus negative 3. If you owe $6 and then you owe $3 more, you're going to owe $9. So besides that, we also have our constants that are like terms, negative 6, the 7, and the negative 9. And again, if it helps you to rewrite those right next to each other, go ahead and do that, is fine. Whatever order you want to do this in is fine. So if you wanted to, with these, if you'd like, you can get your negatives together first. So negative 6 plus negative 9 would be negative 15. And then negative 15 plus 7 would be negative 8. Another option, just doing this in a different order, you could do this left to right. In this case, negative 6 plus 7 would be a positive 1. And then 1 plus negative 9 would be negative 8. Okay, again, whatever order you add those in is not going to matter. So we've got negative 9f minus 8, or you could have negative 9f plus negative 8. If you started with the constant, you could have negative 8 minus 9f, or negative 8 plus negative 9f. So really, it's kind of 4 different answers there for how that could be listed as being simplified. So example 2, they want us to simplify this expression. One thing on this problem, the book fixed their mistake here, so this should be a plus 1/3 x to match up with all the work down below. Anyway, we are going to then add the opposite on that last term, and then we can combine together. Again, if we start with our variable terms, we put those first. Would look kind of like this if you want to group those together. Anytime we're adding or subtracting, we need to get a common denominator. So with 3 and 5, common denominator would be 15. Once again, the book didn't add the opposite here. I think that might be easier for us to see on most problems anyway. So anyway, you combine the x's, you get 2/15 x, and then on the constants, negative 3 plus negative 4.5 would be negative 7.5. So that would be our simplified expression then. So on the try it, they're wanting us to simplify these expressions. So first thing I would probably do anytime on the subtraction, I would add the opposite there. And then we're going to look for some like terms. So like terms, we've got some m terms that are like terms. Different here, instead of fractions, we've got decimals on those. So we can go to combine those together. They are all positives, which makes things a little bit easier for us here. If you want to add 2 numbers and then add the third one to it, you can. If not, you can add all 3 of them at the same time. And just to get some practicing, we're going to do this without calculators. We can handle that. 5 plus 5 is 10, plus 9 is 19. 2 9s is 18, plus 1 is 19, plus 4 is 23. 2 9s is 18, plus 2 is 20, plus 7 is 27, and 2 plus 5 is 7. So for that part, don't forget your variable after all that work. That should be 77 and 39/100 m, 77.39 m. And then we can also then combine our constants. So we've got negative 30 plus 45, and again, if it helps you to rewrite it where they're next to each other, that's fine. These are battling it out. We have more positives, so that would be a plus 15. So that would be our simplified expression for part A. Look at part B. Again, we can go ahead and add the opposite anytime they're subtracting. And then we actually have 3 like terms that involve p. So negative 5/10, if you want to rewrite that as a fraction, negative 5/10, that's the same as negative 1/2 p plus 1/2 p plus 2/3 p, if we look at that part. Normally in this case we would have to get a common denominator with our fractions, but negative 1/2 p plus 1/2 p, those are opposites and they will actually cancel each other out. So with the variable part we're just left with 2/3 p, and then we have the constant, there's only one constant, so plus negative 2 75/100ths. Or you could write this as 2/3 p minus 2 75/100ths. One thing about this problem that we want to think about is the fact that with our terms that had fractions in them, sometimes fractions, some people like to try to change the fractions to decimals. In this case, for example, 2/3 p, 2/3 as a decimal, it's 0.6 repeating. That's not a nice decimal to work with. So my suggestion would be change the decimals to fractions and then get common denominators and things. Occasionally, if you have really nice fractions, when you change to decimals, they come out as nice decimals. You could do it that way, but overall it's generally going to be easier to change the decimals to fractions.